curve. This is what they say. Y-axis pressure, this is volume on x-axis. So what is the pressure volume curve in this one? When we have this thing increasing, heart, your volume is increasing in the heart, and then there is a pressure is also increasing along with it. So the more and more, if it is on this side, it is more telling you how compliant is your heart, how compressible or compliant is your heart. Whereas this is something on the pressure side, which is on the top of it, then it is more of telling you how much pressure is it on the heart. So now if we start with the first, this is the first one. So in this scenario, if we look at the first this thing, then second this, then third point, and then fourth point. So imagine this thing is a heart, right? So if you imagine this thing is a heart, so what is the scenario in this one? We'll have a, now in this one we'll start with the first end of a diastole, right? So in this end of a diastole, we'll think when the heart is fully dilated, it is fully pumped up, and in this scenario we have basically with the increasing diastole, we have more and more pressure building up. So this point is known as isovolumetric contraction. Isovolumetric contraction. In this, you can zoom it out and see this one. Okay, so the pressure is building, and in this scenario, your more and more heart flow is increasing. So heart flow in this one is increasing, pressure is building, or your blood flow is increasing in the heart. So this is one. Then after that, there is from one to second point, then there is this thing for your valve gets open. So here you have your aortic valve getting open, and your blood is going out from the heart. So think this blood is going out from the heart, and now blood is flowing out, and this is the end of a systole. And you can see this is, if this is an, imagine if the volume is decreasing, imagine this is a heart. If the volume is decreasing, means your heart is pumping blood, ventricles are pumping blood. So this is an end of a systole, as I have written in this one. There is an end of a systole, and now this aortic valve gets closed. Then there is an isovolumetric pressure decrease. So this is isovolumetric pressure decrease is here. So it is going like this, and like this. Now this is known as isovolumetric relaxation. This was isovolumetric contraction, right? Now this is isovolumetric relaxation. So in this point, the heart is filling with the blood, but there is no volume in it. So it is still the pressure is going down, and volume is on the same level. So there comes a point when the your ventricles and atria are at the same point, and then your ventricle become more relaxed. In this point, mitral valve gets open because pressure in the atrium is built up so much. There is a sudden gush of blood into the ventricle. So from here it goes again to here, from fourth point again to the first point, and here it comes the S1 sound. Here it comes the S2 sound. S1, S2, and after S1 there is this thing called S3. When there is the ventricles are full of blood, so there is a reverberant sound which is called S3, which can be heard in some of the scenarios. And then there is this thing called S4, end of a diastole. Just in a pre-systolic phase, there is this S4. Okay, so in this pre-systolic phase, there is the chances of S4. So now, if you join these lines, as you can see, if you join these lines, what will happen? If you pressure volume curve, if you join all the line 1, 2, 3, 4, so it will show a two curve line. So this curve is basically a compliant curve, and this curve is a contractility curve. So if this curve is shifting in front, like more towards the volume side, and it is getting less, so it is your contractility is decreasing. So your compliance is basically a compliance is decreasing in this scenario. If it is going up and it is on, then more of your compliance is increasing and your contractility is decreasing. So remember the shift. If it is more and more, if it is going on the so yeah, if it is going more on the contractility side, or if it is increasing, so it is getting more compliant. Now let me just see which all the parts which we can remember from this. So if I take the same diagram and if I explain on this chart, small chart, there is this thing. If it is this curve, if you look at, means this curve. This means how much it is getting more than afterload. So if it is more, if it is more on the left side of the curve, left side shift of the curve, it means it denotes more of contractility and less of compliance. If it is getting smaller in size, it means it is less compliance. The rejection fraction is much more decreased. Your rejection fraction is more increased, and diastolic dysfunction. Diastolic dysfunction means it is related to your relaxation time. So even the heart size has decreased from this previous size. If you can relate with this. This one is the previous heart and this is the new heart. And if the afterload is increasing in this direction, the contractility will remain unchanged, as in this scenario I was telling, but your afterload has increased and your stroke volume has increased. Now in this one, if preload is increasing, if it is shifting this side, and even the afterload is increasing, so again stroke volume from this heart, your stroke volume is basically increasing. Here the stroke volume is decreasing because after from this shift it has become this side. So the volume of the heart has become less, but the contractility is more. So the afterload here is more. Afterload here is also more, but preload is also more. So stroke volume in total is increased. Here stroke volume is decreased. So this is the heart cycle pressure volume curve, and this is all the points which can come in exam. So there is one thing which I forgot to tell you. Exercise. What is happening in exercise? Increased stroke volume, increased contractility. So this is something which is happening in exercise. Okay. So let's move on to next in the valve in next video. You can have a close look at it. Or you just read it.